morning, dear students. Welcome to my next video, that is in integration, the very important 5 marks questions from the model question papers. So first 5 marks, find the integral of 1 by square root of a square minus x square with respect to x, and hence evaluate integration of 1 by square root of 25 minus x square dx. Say, first I will write in the rough work side. Say, whenever this type of term is present, square root of a square minus x square is present, the substitution to be done, put this x is equal to a into sine theta. So I will begin on this side. So I write given question, integral 1 by square root of a square minus x square dx. Say the substitution. I said already, x is equal to a into sine theta. Let us differentiate with respect to x. Differentiate with respect to x both sides. So it is d by dx of left side x is equal to d by dx of right side a into sine theta. Left side d by dx of x 1 is equal to, here a constant, d by dx of sine theta cos theta into d theta divided by dx. Therefore dx cross multiply 1 into dx. Dx is equal to a into cos theta d theta. Say with these two changes, one change is dx, another change is x. I will come back to the main side. So this is integration of 1 by square root of, say, a square as it is minus, this is x, in place of x we have a sine theta whole square into dx. Say I will put this a into cos theta into d theta. Now this is integration of, say, 1 into a cos theta d theta. Let me write in the numerator a cos theta divided by square root of, this is a square minus, say, a sine theta whole square is first a square, then sine square theta d theta as it is. Then this is numerator as it is. Inside the square root, in the denominator, take a square common, a square common. From first term 1 remaining, from second term minus sine square theta d theta in the numerator. And this is same as integration of numerator as it is a cos theta divided by, say, for denominator square root of a square is a, then square root of 1 minus sine square theta is cos square theta into d theta. Therefore, say, a gets cancelled and I will continue over here. So it is integration of numerator 1 cos theta remaining, denominator, say, square root of cos square theta, square root square cancelled. I get cos theta d theta. Cos theta get cancelled. We get integration of 1 into d theta. Integration of 1 d theta is theta plus c, constant of integration. Now I show you what this theta is. But meantime I will write left hand side. Left hand side is our given question. Integration of 1 by root of a square minus x square dx. Now theta, come back to the rough work side. So we have x is equal to a sine theta. Therefore x by a is sine theta, whereas we need theta. Transpose sine here. So sine inverse of x by a is our theta. Therefore, I write this theta as sine inverse of x by a plus constant of integration. So first half of the answer is over, but they have said hence evaluate, means using this as a formula, evaluate the given question. Given question is integration of 1 by root of 25 minus x square. Say I will write 1 by square root of 25. I will write 25 as 5 square. Say 1 by square root of 5 square minus x square same dx. Now please use the previous formula. Say compare. Integration symbol as it is. 1 by ratio same. Square root same. Instead of a square we have 5 square. Or in other words, small letter a is 5. Therefore even on the right hand side where a is there, I should put 5. Therefore this becomes answer sine inverse of x by a. A is 5 plus c. So this is the complete 5 marks solution. Kindly go through. Here is the second question carrying 5 marks. Find the integral of 1 by x square minus a square with respect to x, and hence evaluate integration of, this is also 1 by x square minus 16 dx. It looks like this. And I will tell you, first of all, whenever students see this, some of them think that they have to put x equal to a sine theta. No, it is not correct, because we have x square first and minus a square. It is not a square minus x square with the square root. Therefore, this has to be first of all simplified using method of partial fractions. So I will take the denominator x square minus a square separately, and this could be factorized as x plus a into x minus a factorization. Therefore, our given integrand 1 by x square minus a square becomes 1 by x plus a into x minus a. Now I will resolve this into 1 by x plus a into x minus a into partial fraction, and that will be the answer of this itself. Therefore, I will take this separately, 1 by x plus a into x minus a, and this first, it is a proper fraction. Degree of the polynomial present in the numerator 0. Denominator degree of the polynomial 2. X into x, x square we get 2. Therefore it's a proper fraction, because degree of the polynomial present in the numerator is less than degree of the polynomial present in the denominator. Then ignore in your mind the numerator. Focus on denominator. Denominator, there are couple of terms. Ignore the second term. Concentrate on the first, x plus small letter a. This comes under first rule. So first rule says one unknown a by same linear factor plus, now in the denominator, ignore the first term. Focus on second, x minus a. Its numerator is b by x minus a. This is equation 1. Here a and b are unknown. So let us find a and b. So I will take LCM on the right hand side. Left hand side as it is 1 by x plus a, x minus a. Right hand side multiply both denominators. That becomes LCM. X plus a, x minus a. And now numerator of first ratio into denominator of second ratio plus numerator of second ratio into denominator of first ratio. Cancel the denominators on both sides. Equate the numerators. So 1 is equal to capital A into unknown x minus A is our first term plus B into x plus A is our second term, and this I have a practice of writing as equation star. My aim is to find unknowns now A and B. If I will find A first here, I will write here to find unknown capital A. To find A, you please make coefficient of unknown B 0. Coefficient of unknown B is x plus A. Therefore, put x plus A equal to 0. That is, x is equal to minus A in equation star. We get 1 is equal to A into x minus A, and another minus A as it is. This term we only made 0, so plus 0. Therefore 1 is equal to capital A into minus 2 times small letter a. Therefore capital A is minus 1 by 2a. Now I will teach you how to find unknown capital B here. To find unknown B. To find unknown B, you make a coefficient of capital A 0. That is, put x minus A 0. That is, x is, you put plus A. When you put x plus A, it will become 1 equal to 0 plus B into, say x is A plus A. That is 1 equal to capital B into 2 times small letter a. Therefore, capital B is 1 by 2 times small letter a. With these two unknowns, I will substitute back them in equation 1 and I will start my question over here. Main side. Say, integration of 1 by x square minus a square dx can be first of all written as integration of, it is capital A by, say here from equation 1, capital A by x plus A plus capital B by x minus A dx. This is 1 by x square minus a square is, say 1 by x plus A into x minus A. But that 1 by x plus A into x minus A is capital A by x plus A plus capital B by x minus A. Therefore, look at this. Integration of capital A is minus 1 by small letter 2a. I mean 2 small letter a by x plus A as it is. This plus capital B is 1 by 2 times small letter a into divide by x minus a into dx. Now I will split this. This is integral of minus 1 by 2a divided by x plus a dx. This is plus integral of 1 by 2a by x minus a dx. So from this first integral, I can take minus 1 by 2a common. Integral of 1 by x plus a dx remaining. From the second integral, I can take 1 by 2a common. Integral of 1 by x minus a dx remaining. Remaining part of this, I will continue over here. Kindly follow. So it is minus 1 by 2a. Now, integration of 1 by x plus a is log of mod of x plus a to the base e divided by differentiation of x plus a 1. No need of writing. Then plus 1 by 2a. Plus 1 by 2a into, what is the integration of 1 by x minus a? Log of mod of x minus a to the base e divided by 1, and there is plus c. I will take plus 1 by 2a common, or in other words, yes, correct, 1 by 2a itself common, and here I will write this, say, second term first. Plus 1 by 2a I have taken common. This I will write first. Log of mod of x minus a. And first term I will write now. 1 by 2a out. There is minus log of mod of a. This minus log of mod of x plus a is remaining. Plus c outside. Therefore 1 by 2a as it is, or now I will write the left hand side. Therefore my formula is integration of 1 by x square minus a square dx is equal to 1 by 2a as it is. And this looks like a second law of logarithms. What is second law of logarithms? It looks like log m minus log n. Log of m by n. See, log of m. M means the numerator, x minus a, by that of n. N means denominator, x plus a to the base a plus c. Therefore, this is the formula, but attached to this formula, there is one exercise they have given. Hence, evaluate integration of dx by x square minus 16. So, I will start now. The integration of 1 by x square minus 16 dx, given question, can be written as, not you can change x square, but 16 can be written 4 square, minus outside, okay, dx. Therefore, now compare the given this integral 1 by integral of 1 by x square minus 4 square is the same as integral of 1 by x square minus a square. So, a is 4. Hence, apply the formula. It says 1 by 2a. 2 into a is 4 into log of mod of x minus a 4 divided by x plus a 4 to the base e. Base not written. It's understood. Base is e. Therefore, last line is 1 by 8. 2 into 4 into log of mod of x minus 4 by x plus 4 to the base e plus c. So this carries 5 marks. So kindly go through the solution. Here is a third question carrying 5 marks from model question paper 3rd. Integrate 1 by x square plus a square with respect to x, and hence find integration of dx by x square plus 2x plus 10 means 1 by x square plus 2x plus 10. So this I will begin here. Say integration of 1 by x square plus a square dx. Say you can observe this is plus x square, this is plus a square. Therefore, whenever such a term is present, the substitution to be done is put x is equal to a into tan theta. This I differentiate with respect to x, both sides. So d by dx of LHS x is d by dx of right hand side a tan theta. Dx by x is 1. This is a constant. D by dx of tan theta secant square theta into d theta by dx. I will cross multiply dx. Therefore, dx is equal to a into secant square theta d theta. These are the two changes. One change is x is a tan theta. Another change is dx is a secant square theta d theta. I will continue over here. 1 by, say where x is there, I will put a tan theta whole square, this plus this a square as it is. Dx I will put a into secant square theta d theta. Then 1 into a secant square theta I will write first here. A secant square theta by, look at the denominator, a into tan theta whole square is a square tan square theta plus this a square as it is, last d theta as it is. Now I will take this a square common in the denominator, numerator as it is. So a square common from the first term tan square theta remaining, and from the second term if you take a square common 1 remaining d theta, and 1 a get cancelled, and there is integration of secant square theta divided by this is a remaining tan square theta plus 1 is again secant square theta. It is the identity from your trigonometry. I will write here reason. Say in the rough work side, we have substituted tan square theta plus 1 equal to secant square theta. Therefore, this secant square theta cancelled. There is 1 by a remaining. See, I will continue over here. It is 1 by a constant outside. Integral of 1 d theta, and this is 1 by a into integration of 1 d theta is theta plus c, or it is 1 by a into, let us check what theta is. Again come back to this rough work side. Say we have x equal to a into tan theta. Therefore a transpose comes to the denominator, x by a tan theta, transpose tan here, it becomes tan inverse x by a is theta, and this I will substitute over here, tan inverse x by a plus c, or in other words, we got the formula integration of 1 by x square plus a square dx is equal to 1 by a into tan inverse of x by a plus c. Now using this formula, I should evaluate this integral 1 by x square plus 2x plus 10 dx, which I will start now. Now I will start evaluating the integral given 1 by x square plus 2x plus 10 dx. And my dear students, this denominator should be converted into this form. How to convert? So there is something called completing the square method that I will teach you on this side. Say we have x square plus 2x plus 10. I should write this as a perfect square plus some constant. Say to make it a perfect square, first rule is coefficient of x square should be 1, and in this exercise, say already coefficient of x square 1, therefore do not change x square. Plus, all of you know we should add and subtract square of some number. Which number? How to find that number whose square we should add and we should subtract, and that kindly listen. See, we have here 2x. Can you see coefficient of x is 2? Can you see 2? Now this 2 you divide by 2. 2 already we have, divide by 2. 2 by 2, 1. So you have to add and subtract that 1 square. See, therefore I should add 1 square and subtract 1 square. What happens to plus 10? Remains as it is. See, I will repeat. Take the coefficient of x, that is 2, divide by 2. So 2 by 2, 1. So add 1 square, subtract minus outside 1 square. Now say from here to here, this is a perfect square. This look reads like a square plus 1 square is b square plus 2 into x is a into 1 is b. Therefore this is x plus 1 whole square. If you want, you can expand it back in your mind and check. Say a plus b whole square formula. Say x square, say here, plus 1 square, say here, plus 2 into x into 1 is 2x, which is here. Now what about minus this as it is? 1 square, 1, plus 10. Therefore, x plus 1 whole square. This is say 10 minus 1, 9. This 9, I can write 3 square. Therefore, x plus 1 square plus 9 is 3 square, which I will substitute back here. Integration of 1 by x plus 1 whole square plus 3 square dx. Whereas, what is the formula we derived just now? We derived the formula. Integration of 1 by x square plus a square dx is equal to 1 by a tan inverse x by a plus c we derived. Now I request you, please compare this with this. And can you tell me what we have in place of x? We have in place of x, x plus 1 whole square as it is. What we have in place of a square? We have 3 square. A is 3. Therefore, a is 3. Therefore, I will substitute RHS right hand side 1 by a. 1 by a means 1 by 3. 1 by 3. Then tan inverse. Yes, tan inverse. Of. Then I need x. I said in place of x, we have x plus 1. X plus 1. Divide by a. A is this 3. Then whole thing divided by, see this whole thing divided by differentiation of x plus 1, because it is not a standard form. It is standard form is this. It's a generalization. Is this. So it is in place of x, we have x plus 1 linear factor like ax plus b. So divide by differentiation of ax plus b. Differentiation of x plus 1 with respect to x, which is 1 plus c. And there is some students ignore writing this divided by 1. No problem. This itself is the final answer. Or I can write it 1 by 3 tan inverse of x plus 1 divided by 3 plus c. Or even in the exam, if you do not write this step, no problem. Directly from here, you can write this. Therefore, kindly go through the complete solution. Here is a fourth question. I have selected from last year's model question papers. Find the integral of 1 by square root of x square plus a square with respect to x, and hence evaluate integral of 1 by square root of x square plus 121 dx. First I will begin the main integral. Say integral of 1 by square root of x square plus a square dx. In the previous exercise, I said whenever square root of x square plus a square present, or simply x square plus a square present, say we put x is equal to a into tan theta. Differentiate with respect to x. So d by dx of left hand side x is d by dx of right hand side a tan theta. D by dx of x 1. This is a constant. D by dx of tan theta secant square theta into d theta by dx. Therefore, dx cross multiply 1 into dx is equal to a secant square theta d theta. These are the two changes. See, one change is x equal to a tan theta. Another change is dx is equal to a secant square theta d theta. I will come back to the left hand side. 1 by square root of, say, x square is a into tan theta whole square plus this a square as it is. In place of dx, I will put a into secant square theta d theta. This is equal to integration of 1 by square root of, say, a tan theta whole square is a square tan square theta plus a square as it is. This 1 into a secant square theta, I will write here a secant square theta, and this d theta as it is. Therefore, this is integration of a secant square theta divided by square root of, there is a square common, and in bracket tan square theta plus 1 remaining d theta. Therefore, this is integration of a secant square theta divided by square root of a square a. Then square root remains tan square theta plus 1 is identity. Secant square theta d theta. Therefore, a get cancelled. And what remaining part I will continue here. It is integration of numerator secant square theta remaining. Denominator square root of secant square theta is secant theta d theta. Secant theta get cancelled. There is one integration of secant theta d theta remaining. And this is the formula. It is log of mod of secant theta plus tan theta and plus instead of adding constant of integration c, I will add constant of integration k, small letter k. There is a reason behind it why I will add k. I will tell you later. Now I need to substitute secant theta. So come back to my rough work side. What we have, isn't it? We have x is equal to a tan theta, therefore transpose a. Are you getting x by a tan theta? This we need. This x by a equal to tan theta. Say I will put in the place of this tan theta. Tan theta I will put x by a. That is fine. But I should put something in place of secant theta. All of you know this identity. Secant square theta is 1 plus tan square theta. Therefore, secant square theta is equal to 1 plus, say tan theta, x by a, its whole square. Therefore, it is 1 plus x square by a square. Still, I will continue over here. So, this looks like, say after this it is continued here, secant square theta is equal to, say, a square LCM, a square, it's a numerator, a square plus x square. Then I will go to secant theta. Therefore secant theta is square root of numerator, a square plus x square by square root of denominator, which is a square. Therefore secant theta is root of a square plus x square divided by a. Here I have shown all the steps of simplification of secant theta, but in the exam no need of showing all the steps of simplification of secant theta. You can directly do in mind. That is sec square theta 1 plus tan square theta. Secant square theta 1 plus, directly you can write x square by a square. Then taking LCM, directly you can write mind work. Then secant theta is root a square plus x square by root of a square a. Now this secant theta, I will substitute back here. Say secant theta, root of a square plus x square divided by a. And plus this small letter k. Now this is inside the modulus. Say a LCM, numerator of this, root of a square plus x square plus x and plus k as it is. And this term looks like second law of logarithms, log of n by n. So I will write it log of the numerator, which is x plus, say I will write x first, root of a square plus x square. Then there is a log of the denominator minus log of the denominator a plus k. And now, dear students, please understand this minus log a plus k is a constant, and that constant we shall call it plus c. Therefore, I will tell you the formula. The left hand side of this formula is integral of 1 by root of x square plus a square dx is equal to, right hand side is log of mod of x plus root of a square plus x square. This is plus c, k minus log a plus c. So here we got integration of 1 by square root of x square plus a square dx equal to log of mod of x plus root of a square plus x square minus log a when I applied second law of logarithms plus k. This I said is a constant of integration. See, therefore the formula you are supposed to remember is integration of 1 by x square plus a square dx is equal to log of mod of x plus root of a square plus x square to the base e, and this is plus c, where this constant c is our minus log a to the base e plus k. But I request you commit to memory this as a formula. Now using this formula we have this exercise. Now see the exercise how I am going to evaluate. We have integration of 1 by square root of x square plus 121 dx. This 121 can be written as 11 square. All of you know 11 square dx. Therefore please compare this integral symbol with integral symbol. 1 by, we have 1 by. Square root, we have square root. X square, we have x square. A square, we have 11 square. So A is 11. So A is 11. So if you apply the formula, it is log of, say look at the right hand side, mod of x plus root of x, A square. A square, 11 square plus x square to the base e plus c, or in other words, last line. The answer is log of mod of x plus root of, say 11 square. I can write it back, 121 plus x square plus c over. Here is the next possible 5 marks question. Find the integral of 1 by a square minus x square with respect to x, and hence evaluate integral 1 by 16 minus x square dx. Again I will tell you to integrate this, do not do any substitution. Instead, apply method of partial fraction. So I will come back to the rough work side. So a square minus x square factorization is a plus x into a minus x. Therefore, when you resolve this 1 by a square minus x square, first of all it should be written as 1 by a plus x into a minus x, and this 1 by a plus x into a minus x can be written as two proper fraction, say capital A by small letter a plus x plus capital B by small letter a minus x. This is I will call equation 1. As before, I will take on the RHS the LCM. LCM is, say, a plus x into a minus x. The numerator of first term into denominator of second term plus the numerator of second term into denominator of first term. So denominators get cancelled on both sides. Equate the numerators. Left hand side numerator 1, right hand side capital A into small letter a minus x plus capital B into small letter a plus x, and this I will call equation star. Now I would like to find unknown a first. To find unknown a, so this all writing not necessary in exam to find a, to find B, etc. But here, since everyone should understand, I am explaining it in detail. Otherwise, from directly this step, 1 by a square minus x square is equal to 1 by a plus x into a minus x. You can write directly this equation 1, and from equation 1, you can directly write equation star. And now to find a, say to find unknown a, you please make the coefficient of b 0. What is the coefficient of b? A plus x 0. Put a plus x 0. That is, you put x minus a is equal to minus a in equation star. We get 1 equal to capital A into small letter a minus x is minus a. Therefore, 1 equal to capital A into, this is a plus a, 2a. Therefore, we get capital A unknown, 1 by 2 small letter a. Similarly, to find unknown b, please make coefficient of capital A 0, that is a minus x 0. So put a minus x 0, that is put x is equal to small letter a. In equation star, we get 1 is equal to capital B into a plus x is a. Therefore, 1 equal to capital B into 2a. Therefore, capital B is 1 by 2a. With both these, I will come back to the question here. First of all, the question can be rewritten. Say 1 by a square minus x square is 1 by a plus x into a minus x dx, and this when you resolve into partial fractions, it is capital A by a plus x plus capital B by a minus x dx, and this is integration of, say, capital A unknown here, 1 by 2a, 1 by 2a divided by a plus x, and plus capital B is again 1 by 2a, 1 by 2a by a minus x dx. Therefore, this can be written as one integral is 1 by 2a by a plus x dx, if I could split. Second integral is integral of 1 by 2a divided by divided by a minus x dx. Or I will continue the main answer here after this. Say 1 by 2a constant can be taken out from first integral, an integral of just 1 by a plus x dx remaining. Here also plus 1 by 2a outside, integration of 1 by a minus x dx, or 1 by 2a into, now what is the integration of 1 by a plus x? So log of mod of a plus x divided by differentiation of a plus x is 1 with respect to x, plus 1 by 2a. This is also integration of 1 by a minus x dx. Log of mod of a minus x divided by differentiation of a minus x with respect to x is minus 1. Plus constant of integration c. So I will repeat here, integration of 1 by a minus x is log of mod of a minus x divided by differentiation of a minus x with respect to x minus 1. And now, do you agree? 1 by 2a common in both the terms. What is remaining here? Log of mod of a plus x, and this middle it becomes plus by minus a minus, 1 by 2a taken out. Log of mod of a minus x base a plus c, and this is again applying that of second law of logarithms, log m minus log n. So 1 by 2a log of mod of a plus x divided by a minus x base a plus c. Say, what is the second law of logarithms? Log m minus log n, log of m by n, or in other words, we got the final formula, integration of 1 by a square minus x square dx is equal to 1 by 2a into log of mod of a plus x divided by a minus x base e plus c. This is our formula derivation is over. Now, see the question. Integration of, there is 1 by 16 minus x square. Therefore, this 16 should be written as 4 square. Say, integration of 1 by 16 minus x square dx we have. Therefore, this 16 you write 16 as 4 square minus x square dx. Now, please compare with this formula. It is in place of a square, we have 4 square. That means in place of a, we have 4. That means substitute on the right hand side also. Wherever there is a, put 4. So 1 by 2 times a 4 into log of mod of a 4 plus x divided by 4 minus x to the base a plus c, and thus you can write last line on your own. Say 1 by 2 into 4, 8 it is. 1 by 8 log of mod of 4 plus x by 4 minus x plus c. Kindly go through the solution. Here is the next 5 marks question. Find the integral of 1 by square root of x square minus a square with respect to x, and hence evaluate integral of 1 by square root of x square minus 289 dx. Say here we have to make a substitution, not partial fractions. So integral of 1 by square root of x square minus a square dx. Don't think that this integral is already done. No, that time in the first question we solved integral of 1 by square root of a square minus x square, whereas this is plus x square minus a square. So here the substitution to be done is put x is equal to a into secant theta. Therefore, we differentiate with respect to x. D by dx of x is d by dx of a secant theta. Therefore, d by dx of x1, this is a into d by dx of secant theta is secant theta into tan theta into d theta by dx. Therefore, this dx cross multiply, we get dx is a secant theta into tan theta d theta. Therefore, the question becomes integration of 1 by square root of say x square. X square is a secant theta the whole square minus a square as it is, and dx is a secant theta tan theta d theta. Now numerator is integral of 1 into a secant theta tan theta as it is, this is as it is, divided by square root of say here a square secant square theta, then a square common. So when I take a square common, it will be inside this bracket from the first term, secant square theta from the second term minus 1 remaining, and d theta. Therefore, this is a into secant theta tan theta divided by square root of a square is a. This is square root of say secant square theta minus 1 is tan square theta d theta. Thus, a gets cancelled. Not only that, a root of tan square theta is tan theta. Tan theta with tan theta get cancelled. Therefore, just integral of secant theta d theta remaining. And this is a formula. Integration of secant theta d theta is a formula, and this is equal to log of mod of secant theta plus tan theta, and I will add now plus k, not c. Once I told you the reason before in one of the sums why I will add k, not c. That later you will come to know. Now let us substitute for secant theta and tan theta. So come back to the rough work side. Say we have x equal to a secant theta. Therefore, from this equation, will you get secant theta x by a? This I will put here. Log of secant theta is x by a plus. Now tan theta, you know, this is the identity. We have secant square theta equal to 1 plus tan square theta. This implies secant square theta minus 1 is tan square theta. By the way, what is secant square theta? X by a. X by a whole square minus 1 is tan square theta, or it is x by a whole square is x square by a square. See here a square LCM, numerator x square minus a square is tan square theta. Or what is tan theta? From this it follows tan theta is square root of x square minus a square. Square root of x square minus a square by square root of a square is a. That I will put here. Square root of x square minus a square divided by a plus k as it is. Now this is inside modulus a, say small letter a LCM. This is x plus root of x square minus a square as it is plus k. This we apply second law of logarithms. The log of the numerator x plus root of x square minus a square, and this is minus log a plus k. Thus I will write here integral of 1 by root of x square minus a square dx is equal to, the formula is log of mod of x plus root of x square minus a square base a, and this minus log a plus k is constant of integration c. Where what is c? Constant of integration c is minus log a plus k. Now with the help of this formula I should evaluate this integral. Hence we got the formula. Integration of 1 by square root of x square minus a square dx is equal to log of mod of x plus square root of x square minus a square base a plus c. Now I will teach you how to evaluate this integral. So it is integration of 1 by square root of x square minus 289 dx we have. You know, it is integral of 1 by square root of x square as it is minus the 289 is 17 square dx as it is. So therefore please compare this standard integral with this question. Integration symbol as it is, 1 over ratio as it is, square root as it is, and first we have x square minus in the middle as it is. In place of a square we have 17 square. Therefore small letter a is 17. Therefore where there is small letter a on the right hand side, put a 17. It becomes log of mod of x plus root of x square minus a square 17 square base e plus c. And this can be written as log of mod of x plus square root of x square minus 17 square 289. It is minus out. It is square only for 17. Therefore minus 289 plus c. Kindly go through the solution.